Hey guys, so today our focus is arithmetic and geometric sequences. Next class, we're going to look at imaginary numbers, matrices, and then you guys have a test, mini test, big quiz on all this stuff that we've talked about, getting you guys ready for the ACT. Don't forget about the test dates and registration dates. The first ACT registration date is February 29th, and the first SAT registration date is February 14th. So keep those in mind and make sure you guys are preparing yourself for both the ACT and SAT, and that you guys are taking this seriously, because this is all the stuff that you guys need to know to be successful. So we are going to start with arithmetic sequences and then talk about geometric. This is something that you guys learned back in 9th grade. So nothing new, stuff that you guys have seen before. Arithmetic, this is going to be adding and subtracting. And it's a sequence of terms that have a common difference, because you're going to do some subtracting. While geometric sequences is multiplying and dividing, is a sequence of terms that have a common ratio, meaning we are going to divide. And I'll show you what that means when we get down here. Your general formula for arithmetic sequences is A plus D times n minus 1. For geometric, it's A times R raised to the n minus 1. So quite similar. The only difference is one is multiplication, where the other one is just adding and subtracting. So let's look at a couple of examples. I'm going to have the formula staying at the top so we can refer back and forth to those. We're only going to look at this one section here and then go on to the next page. It says, are the following sequences arithmetic, geometric, or neither? If they are arithmetic, state the value of D. If they are geometric, state R. So looking at this, I'm going to use a thinner pen. We're going to do the difference. So part of this is trying to, you can kind of glance at it and see if it's going to be adding and subtracting or multiplying and dividing. I'm looking here, these numbers aren't getting huge as we continue on. So all you do is take your calculator or in your head, and all you do is do 12 minus 6, which is 6. See if that works all the way. 18 minus 12 is 6. 24 minus 18 is 6. So our difference is the same, and you do need to check it for pretty much everything, because it could be that this is 6 and this is 6, but right here is 7, and then it's neither. So just be careful on that. They might try to trick you. So since they all have a same common difference, this is an arithmetic sequence, and the common difference is 6. So this is a common difference. Then we look at our next one. So we're, again, 6 to 11 to 17. I'm not multiplying. These are still general numbers. So I look at my difference. 11 minus 6 gives me 5, where 17 minus 11 gives me 6. These are not the same, and if I were to use my calculator and do 11 divided by 6 and 17 divided by 11, these are not the same either. So this is neither, because they do not have a common difference and they do not have a common ratio. Let's look at the next one. As I look, I see it's getting a lot bigger. So this automatically tells me that this is going to be, if it is one, it's going to be geometric. So you start out dividing. And we're going to do 14 divided by 2 is 7. 98 divided by 14 is 7. And 686 divided by 98 is also 7. So these are all the same. So this is a common ratio because we divided. So this is geometric. And the common ratio is 7. So this is how this works. So it's not super complicated. Might take a little bit of time. I highly recommend using your calculator because you don't want to make any silly mistakes, especially when you're taking the ACT or SAT. Let's keep going. So I'm looking here. This looks like half to me. So this looks like it could be geometric. So we're going to look at this and find out. So if I do this, 80 divided by 160, like I said, you can put it in your calculator, is 0.5. 40 divided by 80 is 0.5. 20 divided by 40 is 0.5. And just to make note, we're always starting from the second term back. So this is my first term. I do the second term divided by the first. Third divided by the second, and so on and so forth. Just make sure you keep that pattern. So I have the same common ratio. This is geometric. And the common ratio is 0.5. And it makes sense because if I'm multiplying by a decimal, it should be getting smaller, which it does. Okay, now looking at this one. When it comes to having some negative signs, if they stay the same, if they're all kind of negative and then going to positive, the only way to do that is by arithmetic. Whereas here they're alternating. The only way to get this is by geometric, and I'll show you why. So looking here, I'm looking at, I know that this is probably going to be arithmetic because it seems to be fairly similar in distance. So we're going to look at this and do 25 minus a negative 40. So this is why this works. Negative 25 minus a negative 40, and we get 15. Negative 10 minus a negative. Remember, when you subtract a negative, it makes it positive. 25, 15. Same thing happens when I do 5 minus a negative 10. It's 15. So this is a common difference. So this is arithmetic. And the common difference is 15. And so last one, like I said, if it's alternating, it's probably going to be geometric if it is. Otherwise, it's probably going to be neither because that's the only way to get this type of pattern. So looking here, again, I'll show you why. Negative 21 divided by 7. A negative and a positive gives me a negative. 63 divided by negative 21, negative 3. Same thing happens here. So it's the same common ratio, so this is geometric. And the common ratio is negative 3. All right. Now, we're going to look here. So I'm going to keep the formulas kind of at the top so we can reference them, and we're going to do a couple more problems to see what this looks like. So it says, determine if the sequence is arithmetic or geometric, find the common difference or ratio, and then it says, write the explicit formula. So we're just going to deep dive a little bit more. So here, like I said, one, I see that the numbers are drastically getting bigger, and it's alternating signs, so I'm pretty sure this is going to be geometric. So I do negative 18 divided by 3, I get negative 6. Here, I get negative 6. And I also get negative 6 here as well. Now for our formula, so our common difference is negative 6. And this is geometric. And so now to write our explicit, A is your first term. So I'm going to write that here. D is our difference. And N is our term. So whatever term we're trying to find, which I'll show you in a little bit. Same with geometric. A is the first term. R is now the ratio, and then N is the term we are looking for. So our explicit meaning, we're not going to find a term because we don't know what we're looking for, but I know that my first term is 3. This should be an R, it's a ratio. My ratio is -6, and it's raised to the N minus 1. We don't know what that N is going to be. We'll know it for 3 because it tells us we're looking for the 12th term. So then looking at number 2, again, I see negatives are kind of consistent. It doesn't get drastically, it kind of does get drastically, so this could go either way. So we're going to take a look. And so -2 minus a -1 is -1. -6 minus a -2 is -4, so it's not working. By subtraction, if I do -2 divided by -1, I get 2. -6 divided by -2, I get 3. So this isn't working either, so this is neither. All right, so now I'm going to fold this so that we can look here a little bit better. And now we're going to actually find a term based on a sequence. So for this one, we do 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. This tells me it's geometric. And then I know that my common ratio is 3. And then we sub it in. First term is 2. That's where A is. Times our ratio is 3. And they're telling me I'm looking for the 12th term. So 12 goes in for N minus 1. Then you can just put this in the calculator. 2 times 3 raised to the parentheses 12 minus 1. And we get 354,294. Okay, let's do one more together. We have, I see it kind of looks fairly, I see a 9, 0, 9. This looks like it's probably going to be arithmetic. So let's test it out. -9 minus a -18 is 9. 0 minus a -9 is 9. 9 minus 0 is 9, so this is arithmetic. The common difference is 9, and now we're going to sub it in to our arithmetic formula. So A is our first term, which is -18, plus our difference is 9. And then it tells us to find the 24th term, so it's 24 minus 1. And again, for stuff like this, use your calculator. You don't want to miss questions on the ACT and SAT for simple mistakes. Plus 9, 24 minus 1 gives us 189. So on here you have a couple extra problems where you're not going to do this bottom section, so you can cross that out. We also didn't do the bottom section of this as well because they don't go along with the type of questions you see for the ACT. You guys have a Go formative where you are working on some ACT prep questions that come straight from the book, as well as some additional extra practice to help you guys master this. Like I said, next class we'll review imaginary numbers, which we talked about first semester, and then we'll get into matrices, which is a pre-calculus standard. So unless you're going to pre-calculus, you're never going to see that again. And, well, you might see it in college, but in terms of high school, you won't see it. So in order to get ready for the ACT or SAT, this should truly help you guys be successful on that. So enjoy.